Hi guys, welcome to another Learn Electronics Repair video. If you've been watching my recent videos, you will have seen this before. This is a little Radeon vintage graphics card. Not so vintage because it is PCIe. And this was amongst a bunch of various cards that I got at the car boot sale, the flea market a couple of weeks ago. And I was using these cards just to demonstrate some of the techniques in GPU repair, because basically anything that you need to know to repair the latest GPUs, you can learn the skills repairing these. And this one had all the voltages present but just didn't work, and I said on the video it would be interesting to see if we could change the GPU. It's not a particularly big one on this, with basic equipment, not using my BGA Rework Station, which I do have. So I created a poll, voting poll on this one, and asked people to vote whether they'd like this to be removed on the BGA Rework Station, whether we were going to do it on a high-end hot air station, a quick 861DW, which is a pretty decent hot air station, or whether we should use something cheap and simple and nasty like a 858D. And of course, I knew what was going to happen. Most people voted for the 858D because they like making my I wouldn't say they like making my life difficult, but I think they wanted to see if I actually could do that. So the votes came in, and there we are. I was originally just going to remove it, reball it, put it back on, and let's see if it actually fixed the problem. In the meantime, a couple of eagle-eyed subscribers noticed a couple of these capacitors were broken. So I then used this card to make another video. I went on to use the graphics card on this video, where we had a very in-depth look at the PCIe interface, how the PCIe lanes work, and it's been a very popular video, 8,500 views, and it was only published 9 days ago. People like this one. So during this video I actually repaired the card, so it's now working, but I decided we'll keep the poll going anyway, and it actually makes it more interesting because now we can actually have a look to see with a working card if we can remove this, reball it and replace it, and will it still be working. So here we have the results. Yeah, I should have known this. I knew all along this was going to happen. So whether it's some of the slightly more sadistic ones out there, or whether people just think it'd be a good laugh or just very entertaining, there we go. Attempt to remove and reball the GPUs in the cheap 858D hot air. So that's the challenge, and that's what I'm going to try and do today to see, actually, is it possible to do this with low-end equipment? So let's have a look at what the options were, and then let's get stuck in with this option, which we're now going to use. To start off with the three options, this is my BGA Rework Station. It's an LER G720, you can see on there. And I've used this on a number of videos, and otherwise I've used it many times to actually remove and rework and replace BGAs. This machine actually is a hot air machine, so the top nozzle is hot air, the bottom nozzle under the board is hot air, so you have hot air above and below, like having two hot air guns, but you'll see all around there you have the heating plates. These are effectively, I think it's I'd have to look up the spec, and if it's about 1200 or 1500 watt, maybe more preheater. So this machine, although it's hot air, it actually has a preheater. And I think we may find that without some sort of preheating, we can't do this sort of job with a low-end equipment. But this is what we're going to prove today. Just off interest, by the way, this machine actually has an optical alignment system, but I have an intermittent fault on the camera at the moment, one of the wires, so I need to just fix it. That's why I'm not actually getting an image of it. But anyway, that's what I could have used if some of you, or enough of you, have actually voted for me to use that. But no, that wasn't to be. The second option then would be to use the quick 861DW. This is not overly expensive, €230 I think I paid for it. It's quite a powerful hot air station, and it's been reviewed and recommended by a lot of people, and a lot of well-known people in the repair community, how good these machines are. There's also, since I bought this in 2019, there's an A10 8682D, which has the same performance of this one, maybe better. but very similar performance to this one, and it's actually about €100 cheaper. So that was option 2, but no, that wasn't to be either, because most people wanted me to use this. Now, whether this is because they have a slightly sadistic side to the nature, whether they thought it was amusing, or whether this is what you've got and this, you want to know, can this do the job? Yeah, but this is what you want me to use. So this is what I'm going to use. Now, as I mentioned, even my hot air above and below rework station needs a preheater to work. And I may end up using a preheater, but we're going to try without this first. This is a little Corda 853B. It's about €40, and it's a little hot air preheater. So this basically allows me to do what the big machine does, is to get hot air above and below. And we may end up having to use this. Another option would be to use something like a hot plate or an oven. But anyway, let's see first whether or not we can actually get away with using just this machine. As I mentioned, this is now actually a working card. And I think to give ourselves the best chance of success with here, I'm first going to try to remove a GPU from a non-working card, a similar type of card. That's this one. I don't recall exactly what was wrong with this one, but it's something to do with the GPU, I think. But it's an old card. The fact is, old cards like this are very good for experimenting with. And it's very true to say that if the equipment can't remove a GPU of this size, then it's not going to remove one of the large GPUs on a modern graphics card. So basically, this is, it's not that new, but it's an R9 390X 8GB card. It's not that old either. And this is more typical of your modern GPUs in comparison to this one. But as I just said, if you can't remove that one, you ain't going to remove this one. Yeah, so I think it's fair to try with this, and let's see if it can do the job. So I'm just going to remove the heatsink from the scrap board first, and we will use this for the initial experiment. If it's successful and I can remove the GPU with just the hot air without damaging the GPU or the PCB, then we'll have a go on the other one. If it turns out that I can't, then we'll try using the preheater to warm the board and then using the cheap hot air to finish the job. So I've got one of those. That one we're discussing that. Just get the other one out, which I think the little clip goes this way. I think there's one way or the other. Yeah, that way. Okay, so this is slightly larger than ours. Okay, so it's a good one to practice on. So let's have a practice with this. The first thing I'm going to do is to warm the area of the board. So I'm going to use a hot air. I'm going to warm this up from the back. I'm just wondering whether to remove these electrolytic capacitors in case something explodes. But I think we'll throw caution to the wind. I think we'll take the metal bracket off just to give us a little bit less thermal mass, just to give us as much of a chance as possible to remove this. So we'll remove any metal that's on the card. And then let's start and let's see what we can do with this. Let's start by adding some flux. There's only a little bit left in this tube. I've got a fresh one, but we may as well use what's left of this one first. So I'm just going to get some flux. I'm going to go all the way around the edge of the... In fact, no, I'll get some flux. I'll put it on one edge of the GPU. Now let's get the hot air. And let's just warm this up. So I want to melt the flux so it runs down behind the GPU. Yeah, there we go. It's running there. A long time since I've used that thing. But I mean, before I was doing this GPU sort of work, for general, so, you know, removing capacitors and resistors, surface mount ones, and smaller chips, it's okay. It does the job. Okay, yeah, all that's run behind there. You can probably see. Not too hot just yet. Okay, I think I'm just about the end of the tube, that tube of flux now. There we go. Most of it went down behind it. We'll get a bit on the last side as well. Still going. Still going. Okay, I've run down the sides. Now I'm going to get something to work on to protect my bench from the heat. So I actually use the lid off an old satellite receiver, which I can just get. That's what I use. It's ideal for this sort of work. And we can just rest this on it. Sometimes it's worth resting it so it's actually not on the metal if I get the thing to balance. So you know, effectively there's no metal work underneath it, but just for now I'll put it to you. I'm now going to attach a thermocouple on here. I'm interested to see how much heat I can get into this PCB. These temperature meters, I got 2 of them for €10. They're about 4, I think maybe 2 for €8. So these are very cheap, and it's worth getting 1 or 2 of these. You know, even if you're on a budget, that sort of price is worth getting. And this at least will give us some indication of what's happening while we do the job. I've also added a bit of Kapton tape. This may well be counterproductive and may actually prevent me from getting the heat into the circuit board that I want to do. But I'll put it there and I'll just try and protect these capacitors a little bit as well. Try to avoid something exploding because it's messy, yeah. I hope you like the way I do that. Chastise me, but I'll still keep on doing it, yeah. Okay, so we have a bit of tape on there. But as I say, this actually might be counterproductive. It might actually stop us getting enough heat in to actually do the job. But anyway, we've done it. We can always take it off and try without if we want to. So there we have it. We have the temperature meter in shot. Yeah, there it is. So we can see at the moment, that's the ambient temperature of the board. I mean, it is getting quite warm this time of year now. I've just put the aircon on actually, because it was getting a bit warm in the workshop, so it'll probably drop a little bit. The hot air, initially, I've got this on 450. Yeah, 440. It will go up to higher than that. We can try that. But the trick with this is try to get heat into the whole board without burning something. So I don't want to put it too hot if I can avoid it. So what we'll do first is we'll just take these stickers off. And let's warm this board up from the back. Yeah, let's get quite a bit of warmth in this. I'll probably need a cloth or something to hold this as well. I'll just one cloth. Okay, let's give it a go. I will just add that I do have some more nozzles for this, but it's such a long time since I used it I can't actually remember where I put them. So we'll go with what we've got. I could actually try it without a nozzle at all. But first of all, let's just start warming this up and let's see if we can actually remove this GPU at all, and more so can we remove it without damaging anything, you know, the PCB or the chip. So we want no ripped pads or tracks. We just want to remove it cleanly. I'll just move this into shot a little bit, not that there's a lot to see right at the moment. So first of all, I'm going to warm up behind the board. You can see there the temperature I'm reading is from the other side of the board. So I'm having a look to see how much heat I can actually get into this. If I move this away, yeah, the temperature's still climbing, so the heat's definitely going into the board. So let's warm this up until we can get up to maybe about 100. Okay, so we're a bit over 100 actually. We've got up to 105. That's quite a nice bit of heat into this. So let's now turn it over. So I'll need the cloth. And let's come over to the other side. So I'll probably now turn the heating up on this. Yeah, I'm gonna now set the thing up to its maximum of 500. Can you see? Oh yeah, 500. Yeah. And I'm going to use, by effectively controlling the distance, to control the amount of heat that's going into this. Now, for me to unsolder this, judging from what happens with my BGA Rework system, I need to get the actual PCB up to about 260 to know there's enough heat in to actually desolder the BGA. So let's see with this now on full if it can actually get enough heat into this I've also tried to move it a little bit across so it's a little bit off the metal stand. Although the metal stand's actually quite cool, so it's not conducting a lot of heat into there. Can we do this and actually, yeah, you can see it, okay. So I'm just generally heating around it, getting more and more heat into the job. If I take this away, you see straight away it's dropping rapidly, yeah? So there isn't enough heat into this PCB. Anywhere near enough. Look, you see what's happening with it? Again, it's reading quite hard, but as soon as I take it away, the temperature's dropping right down. So you can see the real temperature, once I remove the hot air, is actually, well, let's see where it kind of settles. Yeah, it's not settling any at all, it's just dropping away. Let's see how warm this board actually is. Well, it's less than 120. The board isn't, it's not even 110 degrees. So I'm not sure how long I'm going to have to warm this up, or if it's even possible to get enough heat into the job to do it. Yeah. Let's try balancing this thing so it's away from the metal stand, although the metal stand is quite cool, so there's not a lot of heat going into that. Well, let's try that, see if that helps us to get a bit more heat into it. Okay, that took me like a minute to do that. So I've now got the board suspended between these two, yeah. But you can see that I can't get enough heat in with this to warm it up sufficiently. Let's switch that off. Let's take the nozzle off, so I've got like a wider blast of air basically. Let's see if that actually gets it any warmer. So I'll just remove the nozzle, which I can probably do about toss on this. If not, I might just have to just, yeah, it's get me a pair of pliers and hopefully this will just come off. Start this on something metal so it doesn't do anything bad. Okay, so let's go again. So I've now got a much wider flow of air. And let's see again if we can get enough heat into this to melt the solder balls. Again, I'll just move it away and let's see how fast it drops off. Well, it's not hot enough yet, we can say that for certain. It's getting a bit warmer now. I mean, it's definitely getting a bit warmer since I took the nozzle off. How much warmer, I'm not exactly quite sure. I'm sure you can see if I just come to this. This is not even in the slightest bit loose. Yeah, it's not getting enough heat into it actually desolder. Well, I've spent quite some time warming this up now. Let's see what's happening with the temperature. Are we getting anywhere near? No, we can see we're not. We're not, guys. We're just not, yeah. We're not getting anywhere near enough heat into this to desolder it. Okay? When's it going to settle down? And the board's not going to cool down that quickly from whatever temperature it's at, yeah. It's hardly any warmer than it was before. So I think we're going to have to say, put your comments below. But I cannot get enough heat into this to desolder the chip. And that's a relatively small GPU, yeah. And I can come close, we can give it one last good blast, but in doing so, I risk, if I wanted to reball the GPU, I risk damaging it anyway. Is it even coming close? Let's have a look. No, I can lift the board up by that. Yeah. And how hot is it? It's still not hot enough to melt the solder by quite a long way, yeah. You see how rapidly that's dropping down. Let's see where it settles again. Nowhere near, okay? So, I think we'd have to agree that we cannot remove this BGA with just the hot air, even on maximum airflow, on maximum everything maxed out, yeah? So let's try and give ourselves a chance. Let's see if we can remove this using the same hot air but with a little preheater. So this is the CADA, however you want to pronounce it, CADA I call it, doesn't really matter. A little hot air preheater. They're quite inexpensive, €40 or so. I'll put a link in this video. There's nothing very high tech about this. It just has a knob you have for setting temperature from 120 to 350. I can tell you now it's not particularly accurate, and it doesn't do it by altering the temperature of the air. It just, you'll see this flashes on and off, and the hotter you get, the more on than it is off. So effectively it increases the duty cycle, so it's on for longer and it heats more. Yeah. So with this, we literally switch it on, put the heater on, and you'll see this will flash on and off. Yeah. And that's how it's heating the board. Yeah. And the more we go up, the longer it stays on. Yeah. So that's how this thing works. So let's put this here. Let's put our board on top of it. So it's on top of there. Nothing clever, no fancy stand or bracket. It's just on there. And let's warm us up on here. There's no point in me putting a camera on the front display because there's just nothing to see. So I'm going to switch it on, and I'm going to start putting some heat in here. Again, I have the thermocouple attached to it. You can see how much that cooled down. That board wasn't particularly hot, yeah. So what we're going to do with this, let's try and get the board on the sensor up to about 120. Yeah, I'll try and get it to make a good contact with the board. When we get to about 120, we'll switch this up to the maximum. We'll bring the hot air in from the top on maximum, and then let's see if we can get enough heat into this with both the preheater and the hot air on maximum to remove the BGA. Okay, so you can see I've got up to 110 degrees now. This is set to 272 on the knob, on the dial, yeah, whatever that's supposed to mean. It's up above now, so again I'm going to set the hot air on full. I'm going to turn this up to full on the preheater now, and I'm going to come in with the hot air from the top. And once again, I'm going to see if I can actually get enough heat into this to remove the BGA chip. It's quite warm now to get in with a hand, actually. It's a bit uncomfortable. So you probably need some gloves as well for this work, yeah. I'm going to try and pick the chip up with my right hand, say I'm right-handed. So if it comes off, it's coming. Dropped it. It's coming, but it's so slippery I can't pick it up. Okay. Right, so there you go, guys. It's off. Now, preheater off, turn it to cold and let it cool down. Okay, guys, so it's off, yeah. I haven't bothered to clean up the PCB, but I don't see any ripped pads. It looks like it came off cleanly. I think I probably, when it slipped, I think I dislodged something down here, this one. Normally, if it's a board I'm repairing, I'll take a photograph, either through the microscope or directly off the phone. I'll just take a photograph so I can compare later to see if I've managed to dislodge any components. But this was just an experiment. So I think we can clearly see that with the cheap preheater and the cheap hot air, it's capable of doing the job, at least on this size of GPU. So I won't bother to clean all this up. If I get the other one off successfully, I will do it on that one. But I will show you how to clean and reball the chip. The chip, by the way, also it doesn't look like it's popcorned or bubbled. I mean, obviously you can't say without testing it. It's got a bit of flux on it. Again, if there's any ripped pads, you'll see them because they'll be stuck on here, and they look like a kind of orangey brown colour. I mean, obviously still a lot of flux on this one I haven't cleaned off, but that was like it came off cleanly to me. So let's try the same technique then with the board that's working. Let's see if we can get the chip off, reball it and put it back on. Okay, I've cleaned up the old heatsink compound from this, so we can see, well, we know this is working anyway. Just looking here, we have a little group of resistors here, whatever they are. We have a little group of components here. This block is unpopulated. There's none close here, there's a few up here, and then all around this side and this side is clear. So I think with this one, if we turn the board around and I come at it with the tweezers from this direction, I should have a better chance of lifting this up, and if it slides, it's not going to go anywhere that's going to cause a problem. I mean, I will say on the BGA station, it actually has vacuum pickup, so I don't have to do this. So I'm not particularly experienced at doing it with tweezers. That was probably the first time I've ever actually done it that you just saw. But anyway, we'll do it there. I'll put a bit of Captain Tape this side and this side. But the other two sides, because there's nothing anywhere near, I'm not going to bother. That'll probably help even more so to get heat into the PCB. And as I say, I will just take a couple of photos first so we can check afterwards if we have actually managed to dislodge any components. So as you can see, I've just got a couple of photographs, or 3 photographs, just showing around the board so I can see what was there. Oh, that's not one. So there's just these 2. This is useful. It's a good practice to do this, and then you won't be quite so lost if something goes missing. At least you know it's gone missing, and you'll have a chance. Yeah. Okay, so that's over the 110. I can't keep this in place, I'll take it out. So again, same thing, preheat up to full, hot air in from the top, and let's see if we can actually remove this one. So the hot air is on 500 and maximum airflow, and let's see if we can do it. I'm trying to keep the heat away from the centre of the die a little bit if I can. But obviously at the middle, that's where most of the thermal mass is, the power planes. And we have it. Now we'll wait till that cools down, and then we need to first of all prepare the PCB, make sure we have no ripped pads. After that we need to prepare the BGA, which has come off quite nicely. I think that's going to be okay. So we need to check that out and make sure that's okay. And then we need to reball it. I don't actually have a stencil for this, so I'm going to actually reball this manually by hand. But this is the ghetto version, by the way, so this is really showing how to do this job with a minimum of tools. So we're going to do this without a stencil. That looks quite good. I think all the nearby components are still in place. Obviously I have the photograph so I can actually make a comparison. But I basically, as you probably saw, the thing went sideways again, but I moved it in a direction whereby if it slid sideways it wasn't going to hit anything, and that's fine. So the next job then is to clean up these solder balls. You can normally tell if you've stripped a pad because you'll kind of have some brown ones, but until we've actually cleaned it up we can't say for certain. So we're going to do this using the soldering iron with a nice chunky BC3 tip, and I'll show you now how to actually do it. This is much easier if you warm the board first. In fact, it's easiest to do it when you first remove the chip while the board's still warm, but we can just use our cheapo hot air again, and then we can just warm the area, and then we'll come in and remove the old balls, or what's left of them. So I'll just get a bit of warmth into this first. That should do. Okay, so the first thing we'll do then is to add some flux. I use this one, which is probably a copy. It comes from China, but it works very, very well. I mean, I wouldn't worry about the expiry date on these. So we can just put some flux on there. This will get quite smoky, so I don't have a solder fume extractor here, but I do have a fan, like a computer fan, on a piece, you know, a CPU fan with a shroud on, which I sometimes place just to blow the smoke away from me. But let's just try it first without. So we'll just get some leaded solder. I'm using this one. I need to buy some more soon. It's a 0.7mm, you can see. Just leaded solder, 6040. We got the soldering iron. Set to 344. And let's just make like a blob of solder. So we need to get like a good like ball of solder here. And then once you've got it, you can hover this. So effectively, I'm not really touching the PCB with the iron ore. There's absolutely no pressure. Maybe just under its own weight, it's on the PCB. So you can't hear any like crunching noises that go over here, yeah? Or very little. That makes a good fume extractor. Just blow the stuff away from you, yeah? So you see as I'm going, the ball's getting bigger because he's picking up the excess solder from the board. So we'll come back in again. Again, get a nice blob of solder. Towards the middle is where the power and ground planes are. So sometimes you'll find the solder sticks. If it does that, just get your hot air and just give it a little bit of a warm again and come back with the iron. If the solder's trying to stick, don't try to move it with the iron. Warm it back up a bit first, yeah? But you see I've got this nicely warm, so this is going well. So that's removed the excess solder. Now we have to clean off the remainder. So with this we're going to use some solder braid. I won't put any more flux directly on there, but I'll just get some solder braid. When I was first doing this, I found this extremely difficult to do. In fact, I couldn't successfully do this. And one of the guys on Badcaps forum, I was asking why it wasn't working for me, and he told me to buy this solder wick, solder braid. So I bought some of this, and that made all the difference. Once I got this, I could do the job quite easily. So what we'll do is we'll cut off a bit of braid, and I'll do this so that the heat isn't going back up the braid, drawing heat away from the PCB. About 1 centimetre I have there. I can just again just give the thing a little bit of a warm. This will help. Okay, a bit of a warm. Now I put a bit of flux onto the braid itself. Okay, one little blob of flux on the braid itself. I clean the iron, then I take a bit of solder, and this is important, a bit of solder onto the tip, yeah, like so. And now if you push on the braid, you'll get the heat to flow properly into it. I'm putting no pressure on the board. I just push down on the braid a little bit, but I'm putting no pressure on. Imagine like a hovercraft. I'm just gliding this on the surface of the PCB, so it's touching the PCB, well the braid is, but I've got no downward pressure at all. And now I'm just going to move this braid and blow the stuff away from me. Okay, so gently move this braid on the PCB. I think you can see that like all the pads are coming up, like they go like flat, yeah, they look like they go wider. And that's because I've removed the excess solder. Let's blow it away from himself. Well, you can use a fan, you can use an extractor. But this is the ghetto version, yeah, so probably like an old CPU cooler fan. Okay, so I've gone over that once, and I've removed a lot of that. So we'll take that bit of braid away, and we'll do the same thing again. So we'll come in with another piece about 1 centimetre long onto the board, a little bit of flux on the braid. Once again, clean the tip, a little bit of solder on the tip, yeah, then drop onto the braid, give it a second, and then start again, just gliding this across the board. And take your time doing this, however many times it needs to do it, until you've got all the pads nice and clean. If the braid stops moving, so it sticks, straight away take the soldering iron off, get your hot air, just warm it up again, and come back in with the soldering iron, yeah. Don't try to move it if it's stuck, because that way you're just going to take pads off. Okay, so I think we've now done quite a nice job of that. Get it away. Okay. Just take the braid off, there we go. Right, let's have a look now. We'll clean this up with a bit of isopropyl alcohol and see what we have. So, in with the brush. Somebody was asking me about this brush the other day. I don't know where it came from. I bought like some sort of like kit of soldering aids. It might have even been a mobile phone repair kit with all sorts of little tools and odds and ends and spudges and stuff. And it came in some kit, something like that. So I didn't buy it individually. It's kind of like stiff, like a toothbrush, but this shape, yeah. And it's excellent for this sort of work. So again, I'm not putting any real pressure on this. I'm just a little bit of gentle pressure. I can feel where the flux still is, because it's kind of like a little bit sticky, a little bit of resistance to the movement of the brush, to the movements. So we can just it's moving freely now. So that's clean. I don't see any problems with this so far. There's definitely no ripped pads. So the things you're looking for now is A, are there any ripped pads? B, is there any of these tracks under here where the lacquer, the solder mask, has come off? Because if there is, you'll likely find that when you put it back on, is the ball will effectively merge into the next one. If you do find any problems with the solder mask, you need to repair that. You can get solder mask, which is like UV activated, so you get an ultraviolet torch and some solder mask, and you need to fix that. But this one's come off nice and clean. There's no problems there. Although the balls kind of look like different sizes, all the balls on the GPU are actually the same size, because otherwise the smaller ones wouldn't touch the PCB. Yeah, so we need to find out what size these balls are. There's also a couple just around here, you see here and here, where maybe I haven't quite cleaned off the old solder properly. So this area, I'd say, is worth just going over again. You want them nice and flat, like these are. So if you see any problems, just sort of go back over that area again with the soldering iron, a bit of grid like I was just doing. While we're here, let's have a look at the other side of the board, because obviously we heated this from below. Let's see if we've caused any problems, and I'd say we haven't. It looks fine. You notice nothing came off, nothing fell off, even though I didn't put any tape over here. I needed to get the heat into the board, but you know, like, components haven't fell off, if that's what you thought might happen. That'll most likely a lot factors the fact I'm heating from the top to actually get it above the melting point of the solder. The last thing you need to look for is whether this PCB is flat. So if you see any like raised areas, any bubbled areas, then this is the point to stop, because you'll never get the replacements GPU BGA to fit down. This has to be flat, otherwise it's not going to work. This is done exactly the same method as we've just used on the PCB. So the first thing I would do is just give it a little bit of a warm. Although this is not so important with a small BGA of this size. A little bit of heat just into it is certainly not going to do any harm and may well help you with this. So we'll give it a little bit of a warm, okay? That's fine. Now the same trick again. So we'll take some solder, and we'll just again form a ball of solder, which I'm then going to hover over the BGA, in contact with it but hardly touching it, certainly with no pressure on it, okay? So we can get a blob of solder. You might find it an idea to get some sort of clamp or something to hold it, but I'm quite used to doing these. I can normally just do them like this, especially if we don't have anything to hold it in place anyway. So can you see how I'm floating this ball of solder across the surface? Again, we'll come up with another one. A little bit more. Go. And that ball, again, we can just float it across the surface of the chip. Okay, it's moving a little bit, but it's not really causing me a problem. If you have a reballing clamp or a stencil clamp, you can put it in that to do this. But it's going okay, so we just coming over there. So again, the ball of solder is getting bigger. and we need to come in again fresh with more leaded solder. So you need leaded solder to do this. It lowers the melting point, sorry, and it makes it easier for you. So again, we'll just come over the middle. So that basically has put a lot of leaded solder onto the chip, and I think I've gone everywhere on it. Okay, so we've done that. Next, solder braid, exactly the same as I was doing before, exactly the same solder braid. Get some of this, and again, I didn't put any flux on that, by the way, because it's already had flux on for removal, but now I am going to add some flux, and maybe actually putting some fresh flux would have been a good idea, so I'll just put a bit of fresh flux on this now. Okay, obviously if you clean the flux off, then you needed to add some flux. Same thing, I might just have to hold the thing with a pair of tweezers to stop it moving. A little bit of solder onto the actual braid, and then let's see if we can move it around. If it won't move, just hold the thing down with a pair of tweezers. Okay, and same thing, just blow the fumes away from me. I'm just gliding this over the chip. You can see the braid's getting quite full of solder now, so I'll take it off and we'll come back in with another fresh piece. Same thing, about 1 centimetre onto the chip. There it is. Clean the soldering iron. Little bit of flux again on the braid. And a little blob of solder on the tip. Not enough to flood the braid, but enough to just make a good thermal contact with it. And you may have to do this 2 or 3 times. You can just hold the thing down. Okay. I think I've pretty much gone over this one now. Just double check. Okay. I think I'll just come in with a 3rd bit of braid, just to make sure. Okay. Braid. Just a spot of flux. I'll just try to get a small bit of solder on here. And that'll do. Onto the braid, and then for the last time we'll just go over this. Probably I should have got the fan out to blow this away from me. But we're doing it ghetto style today, guys. Okay, I think that's done. Again, now clean it. Probably the easiest way to do this, I find, is to take out a little plastic tub. This is the bottom of a plastic water bottle. A little bit of isopropyl alcohol. Yeah. And then just drop it in there. Drop the chip into the stuff. And just let it splash around in here for a while. Yeah. We can always just finish off with a paintbrush, but this will get the worst of it off there for us. Okay. Again, we can just come in, we can just use the paintbrush, just get the thing in place a little bit. And again, you'll know when it's done because it kind of like loses, it's like sticky, it has a kind of like a sticky feeling to it when the stuff looks on there. You can feel the brush dragging a little bit. Yeah, now it isn't dragging all the way. Yeah. This stuff isn't particularly harmful to you, by the way. Never done me any harm. If you're squeamish, you can wear some rubber gloves or something. Actually, I'm allergic to rubber in that respect. So well, I used to be when I was a kid. I was allergic to the handlebars on my push bike. Yeah, like the handlebar grips, the rubber things. Okay, there we go. So that's nice and clean. Let's have a look now under the microscope and let's see how that's looking. Okay, there it is. And once again, I'm sure you can see that down this side, I haven't quite cleaned some of the balls off. You see they're not flat like the other ones. So we can soon deal with that. We'll just do it on the bench now. A little bit of braid, a little bit of flux, and we'll just go over this side again. So just put this on here. I can probably hold this with my fingers while I'm doing this actually. A little bit of braid down the side. So you need to get all these pads looking nice and flat, and the same on the PCB. Otherwise this isn't going to work for you. Again, tiny little bit of solder on the iron. Okay, that's all I need. And hold it down. And we'll just go down this side, the bit that I've missed. Couple at the end there. Yep, that looks a lot better now, so let's get this cleaned up again and then make sure it's okay. You can actually tell with these, if they feel flat, if you just rub your finger over. And note I'm using an anti-static mat here, by the way. So I'm just rubbing my fingertip gently over this, and if there's any raised up, even if they might look raised up, if they feel flat, they're okay. Yeah, and all these feel perfectly flat to me. Just go to the middle. Yeah, so that's good, and you want the PCB to be in the same sort of condition. Now we need to reball the chip, and I think you'll see now that all the pads are the same size once I've cleaned it up, yeah, and all the balls are the same size. So I don't have a stencil for this, and we're doing this the ghetto method, so we're going to reball this by hand without a stencil. I've done much larger chips than this, and it's quite easy to do, just a little bit time consuming, but it's certainly not difficult. The first thing we need to know is what size balls this has. To find that out, you can either look up the part number and see if you can find a data sheet, and that will tell you, or see if you can find a stencil for it, even if you don't have one, and have a look at the stencils online, and you should be able to tell, or we should tell you, what size solder balls are for that stencil. The GPU is ready to reball. Normally speaking, you would do this with a stencil, and stencils basically come in two types. So we get direct heat stencils and indirect heat stencils. This is an example of a direct heat stencil, and you would put this into a jig to hold it and place it on the top of the chip, and effectively line it up so you can see all the balls. You know, effectively you can see that all the holes are over the pads, and then you just effectively pour balls on the top. Use a pair of tweezers to make sure there's one in each hole, and that's it. You then remove this. This is an indirect heat stencil, and then put your BGA on top of a hot plate, heat it from beneath, and then the balls will melt into place. To make sure the balls stick, you put a thin film of sticky flux on there. That's what keeps them in place. So that's how you would actually use an indirect heat stencil. And they come in different types. So you get, and I've just shown you, standard ones in various different pitches. You can buy packs of these. I have a whole pack of them. That's a very fine one. And you can also make something like this out of a standard one. So you can use Kapton tape to cover over the holes you actually don't want balls to go in. You can effectively make a stencil fairly easily with a craft knife to actually fit a chip. But this only works where the chip effectively has like a regular grid of balls, and if you look at ours, it doesn't have. So you can see here that these are not lined up with those ones. Yeah, they're not in a regular grid, so you can't make a stencil for this sort of thing. You can buy stencils like this designed for certain types of GPU. I mean, this one even looks a bit similar actually. I'm not sure which this one is for, but you can buy them. But you see, as I'm moving it over here, it doesn't fit ours. It's not the same size. It doesn't have the same number of balls. They don't all line up. Yeah. You can also get stencils like these ones. So these are direct heat stencils. So with these, you have a different type of jig to hold it in place, and again you fill all the holes. This one's actually off one of the LGA sockets. I don't remember exactly which LGA socket it's for. We have a another one here, yeah, with a solid middle area in it. So, in fact, I'm sure there's even tell you what it's for. Yeah, it's for one of the chipsets. Yeah, North Bridge or South Bridge. Yeah, tells you what it's for. But these are made specifically for a particular chip, and I don't have one for this chip. The direct hit stencil, by the way, when it goes into the jig over the chip, you then leave the stencil on the tip with the jig and you heat it from above with hot air. So the stencil stops the balls from rolling away or moving around. The disadvantage of this is if you don't do it right, or sometimes even if you do it right, you can end up with a stencil soldered to the chip. Yeah, it can be stuck on there. This one's similar. This is another indirect heat, but again, although it's similar, it doesn't match ours. I can't get all the solder pads to line up with holes. So we're going to have to do this manually. And that's actually, as I mentioned before, not quite as difficult as it might seem. But in fact, I've just spotted a problem with this. And that's here. Can you see it's not flat? This will not, even if the chip's any good anymore, will not solder down in place. And that's happened because effectively of it too much heat in one area, and that's the problem when I'm trying to do this with basic equipment. I can show you how to reball this, but this is not going to be a successful replacement, unfortunately. So using the equipment, in actual fact, we failed. Let's have a quick look under the microscope at that. Yeah, you can see it there. Just for a tilt, I couldn't really see it when it's flat, but when I tilt it, you can see there. Yeah, there's like a bubble on the chip. That could have happened when I was cleaning the excess solder from the pads, but I think it's much more likely it occurred when we removed the chip from the PCB. Okay, here's the first one I removed. I mean, this graphics card wasn't working anyway, but if this one's okay, we could try reball it and see if it fixes it. Although I don't know what the actual problem was with this one. But you can see, I'm just looking at it now under the microscope. Firstly, I think we've actually lost the capacitor here. Yeah, we have. There's a capacitor missing there. Whether that was already missing, I don't know. But this, again, if you look at the surface of it, it doesn't look even. See the way it's reflecting light? It's a little bit different. It's not as bad as the other one with that obvious bubbling. But again, here, this looks like it's a bit bubbled to me. And again, this is just down to not being able to apply heat evenly. I think it's more obvious on this side that it's not quite flat. In comparison, what we're looking for, this is from a GTX 780 or 780 Ti. I removed some time ago on the actual BGA Rework machine. And you can see with this one that the substrate, the green area around the die, looks much flatter. And if you look at it underneath, yeah, you don't have that kind of like bubbling effect on this one. I know this microscope doesn't exactly focus all the way over it, but can you see that he's basically flat? Just by, if you look at the way it reflects light as you tilt it, that gives you a very good indication of whether it's an even surface. Yeah, you can see that I'm moving over there. Okay, this one isn't quite ready for reballing. It's got a few pads here and there. I can actually feel one as well, a little bit rough. So they're not ready to put new balls on yet, but yeah, there. I can actually feel those with my finger, yeah, that little group. But we can soon sort that out. So this is what we will be looking for in a removed GPU. And this one, can you see as I'm reflecting the light over it? Can you see like a good example here? Yeah, here. Can you see it now? It's not even the way the light's moving over it in comparison to this one. So I don't think this method is going to work. This is a reballing jig for the indirect heating type of stencils. So basically you would put your chip in there, that sits over the top, and then you can slide this around until it gets into the right position. You loosen these little retaining screws. slide it so that it's directly over all the pads, and then that's how you reball your GPU or the BGA, Northbridge, PCH, whatever. And this is kind of magnetic as well, so it's a bit stiff to move, so it's quite easy to use for that. But I don't have a stencil, so I'm just going to use this to hold the thing still. If you don't have something like this, to reball it manually, you definitely need to find some method to hold it still. So you need to hold this in here. And we do this just by effectively adjusting the clamp. That's going wider. There's a few odd balls in the bottom there, as you can see. You can see it's coming in inwards. So I just need to adjust this to hold it still. If you haven't got one of these, you'd have to find some method to keep it still while you actually reball it. So that's in there. Yeah, and that's not going to move. So to reball this, first of all, we need a little bit of flux, but we don't need much flux. If you put too much flux, then effectively the balls, once you start warming up, will start to float around. So I normally put a little bit of flux in the middle, like so, and then I use a paintbrush. You can see I've used this many times. I'll just give it a little bit of a wipe over, actually. And now the ends come off the paintbrush. Typical. Okay, I'll just clean it off a little bit. Probably I should find a fresh one, actually. But I'll take the paintbrush and I'll just spread a bit of this flux over the chip. Yeah, and you want a very thin coating. I'll give it a little bit more. It's easy to take the excess off, but we want to coat this directly over the chip. And this flux is quite sticky, so this is what's going to keep the balls in place once we put them on with tweezers. And they'll keep them in place until we heat it up. Okay, so that's just a very fine amount. It's just kind of like shiny, if you can see what I mean. That might even be a little bit too much. I'll just again clean the end of the brush. Okay, we'll just, you see it's shiny, yeah. I think you can also clearly see where it's bulged. Yeah, it's catching the light here. Yeah, can you see it there? It's easiest to see it in the reflected light. Okay, so that's there. The next question is, what size balls do we use? Now, normally I'd look up a data sheet for the chip, and I can't find one for this chip, and I can't even find a stencil for this chip. Just thinking if I can find a stencil, I can look up the size from the stencil. And the same for this one. I couldn't find for this one either. But looking at a 2, they're probably of a similar size. Yeah. So we're kind of going to have to try. I'm just going to try a few balls, place them on, and see whether they look right. Yeah. So let me get a few solder balls and let me try and work out what size to use. You'll definitely have to buy some solder balls to do this. I actually just bought a whole pack of them in different sizes. I'm guessing it might be a 0.55. It's just a guess. But we'll try with that one first, and then we can, obviously, if we think it looks wrong, we can use something a little bit bigger or a little bit smaller. So in here we have solder balls. I'll just put a few into the lid for now. So I've just got a few. You see them in there, yeah? And let me just try placing 1 or 2 of these on the chip, and that will give me a good idea if they're too small, if they're about right. I lost a bit of the sound recording there for a moment. I think there's something, a bad connection on the microphone. But anyway, you can see what I'm doing. So I had to clean more of the excess flux off this. It was too much. If it's kind of like swimming around in flux when you move them, it's too much, yeah. So what you can see I am actually doing here is I'm just literally putting the balls onto the pads. It's not difficult. You can do it. I'm using the microscope, but I can also do it under the bench magnifier as well. I find it a little bit easier under the microscope. So this is all it's a matter of. There's nothing difficult about this. It takes a little bit of time, but there's nothing. You know, it's not a job that's difficult. So I'm going to carry on doing this, and when I've placed them all, then we need to effectively heat it up and let them melt onto the pads. The fact that they're not central exactly on the pads, you can see as I'm placing them, it doesn't have to be exactly in the middle, because once the heat comes on, they'll kind of like center up on their own, and you'll see that a little bit later. So for now, let me just continue just moving balls around and sticking them onto pads. I've done the lion's share of it now, as you can see. So it's just a matter of just finishing this off now, coming down this, last part. It's best to kind of like work your way across like at an angle or in a line, so you effectively you're not leaving gaps in which you need to go back into to get a ball in place. And sometimes you might just have to reposition one as well. They're not that even on the pads, but I did mention, and I will say again, that doesn't really matter, yeah. As long as you're not touching each other, and there's one ball on each pad, that's all you really need to do. And the rest, as you will see, will sort itself out. Of all the skills you need to learn to do this sort of work, this is probably one of the easiest. It's a little bit, it's more kind of like time consuming than anything else, but at the end of the day, it just takes a bit of patience, and patience costs nothing, yeah. Just, work your way through. If you've had enough, have a little break and come back. I mean, I did actually stop around the halfway point on this, or probably less than halfway, about a third, to take some lunch, and then I just came back and continued with this. And there we have it. All the balls are in place. So what we now need to do is to warm this from underneath. I'll show you how I do it, but obviously there are various different ways we could do this. The way I do this is to use the preheater again, but you can get a little hot plate. You can actually buy them for this, like Reball with hot plates, or even like something out of a kitchen, a griddle or something like that. This is just a base off an old soldering iron stand. So this is where like the wet sponge basically went. And I'm now going to take my BGA and put it into here. Now when I do this, I'll probably knock a few of the balls off, but that's just kind of like the way it is. You can easily line them back up. So I'm just going to loosen the thing so I can actually get hold of it. Lift the chip and just gently place it into here. It's stuck to my finger slightly, so I'm just going to use the tweezers. And I did take a few balls off the end of my finger. So I'll now just effectively just use a magnifier and just replace the few that I might have dislodged. And then we can heat this up and solder it. So there's our Reball chip. I'm just going to now warm this up from underneath. You don't really need to use a thermocouple to measure the temperature of this, because basically if you look, you'll actually see the balls melt. So we'll switch it on, put the heater on, and I'm going to warm it up fairly quickly, so I'll just get it going a little bit, then we'll switch it to maximum. And if we get one or two balls that kind of like merge together into a bigger ball, we can fix that without starting again. So now let's just warm this up and wait till something happens. It's happening. Can you see it happening from the middle? And gradually working outwards from the middle. We're kind of like all pulling in and standing up. Yeah. When it gets to this point, often I'll just give it a little bit of hot air now from above as well. Just to help get the ones around the edges. Okay, that was good to me. So we'll now switch the heating off and allow it to cool down. I think I have one solder bridge that I can see, but we can soon fix that. Maybe two. So here's the Reball chip. You can see where the damage was earlier, where I effectively delaminated it due to the bad distribution of heat, basically, and that's due to the equipment we were using. But we have a couple of problems. So we have, I can show you, I'm sure you can see anyway. So we have one here, which is moved effectively, this one, and we have, I think there's probably one extra ball where I caught it with my finger and I had to just do it under the magnifier. But it's easy to fix this, so we just get a little bit of flux on the two damaged bits, and we can remove those and then just redo those parts. This might accidentally remove a couple more balls in the vicinity, but that's not going to be a problem. So we have one there, that we need to just sort, and we have one here that we just need to sort. So we can get a bit of flux on that. We can get a bit of desoldering braid, and let's see if we can actually remove those without accidentally removing any more. But if we remove half a dozen, it's going to be so simple to actually replace them, it's not really a problem. So let's just, I'll use the microscope, it's easy for me to look down the microscope. So I have one problem here. Okay. And I have one problem here. Okay, here's the chip after the second attempt. So I've fixed the ones that were slightly run into each other. Now it's good, apart from that initial bit of damage, which we can't do anything about. But it's not under here. I mean, I don't think it's going to work. And this is the problem when you can't get heat in evenly. I've also noticed that some of the balls seem slightly bigger than others, even though they all came from the same bottle. I don't know whether this is something to do with you know, buying these sets of balls from AliExpress, but it's ready to go. So we now need to put this onto our board, and let's see eventually what happened. So now I need to put a bit of flux onto the board. I'll just switch that preheater off because it's a little bit noisy. It was on blowing cool. So we need to put again some flux on the board, but not too much. So I'll get some flux on here, yeah, and we'll use the paintbrush again, and I want to evenly spread this across the board. Okay, and then I'll wipe off the excess with a bit of kitchen roll, losing the end of the paintbrush. And I'll do this again. I'll do this several times to reduce the amount of flux actually on here. So we want it to go everywhere, an even coating. But if it's too much, once we get the heating again, the BGA will start to float around, and we need it to stay in place. So we'll just keep going like this across the paintbrush, and then remove the excess with some kitchen roll, and just swing it round through 90 degrees, and we'll go again. And what I'm looking for is a kind of like an even coating, so it's shiny, but it's not swimming in flux. Okay, let's just go again this way. Let's have a look. Yeah, that's probably, I mean, it might still be a bit much actually, but it's getting there, yeah. So we're going to just wipe a bit off, and we'll once again just try to run over with the brush, swing it around the other way 90 degrees, and go again. Okay, I'm fairly happy with that. It's kind of shiny, so there's flux on there, but it's not swimming with it. We're going to do this the getaway, so we're going to manually place it. So we need to put our chip in. We can see the dot, which is pin 1, and the slanty bit there. So I'm now going to position this. I'll use the microscope again, it's a little bit easier for me, and the tweezers. I'm going to get it so it's centered within this line that's running around the edge of the chip. Okay, so we need to just get this into the middle. I can't zoom out any further on the microscope. That's the maximum zoom out. I can see much wider in the microscope through the lenses, but the camera, I have a reducer on there to 50%, and I probably won't want a 30%, but I'll have to buy one, and I can probably get the microscope to give me the same field of view through the camera and with the lens. But I can just see the line on the edge. Yeah, I can just see the line. So that's in, that's centered. So this is just a matter of now of the same process of removing it. So we're going to heat it up with the preheater, use the thermocouple, get it to about 110 degrees, and then we're going to take it from there. So the BGA is certainly soldered down. It's certainly fixed. I think if I probably can't get the microscope high enough to see, but yeah, that's as high as up. Let's have a look. Can we see under the edge of it? No, not really. Maybe just about. It's soldered for sure. It's soldered in place. But again, we seem to have a problem with a bit of delamination of the substrate, and this appears to be the problem with this method. It's not getting enough heat into the job that's a problem. Once you have a preheater, it's getting enough heat into it evenly, and that's where it seems to go wrong. But we can try. What the hell? Why not? First thing, let's just check we actually have no short circuits on this, and then if we don't, let's stick it in the computer and see what it does or doesn't do. So we're on ohms range. Yeah. Let's have a look. So we have a couple of big VRMs on here. One's RAM and one's vCore. So let's go to the this one first, whichever it is. Let's scan to ground. And so what we have. Well, we have a short. So all this actually this is achieved is the GPU is now short. So on the other one, this is the memory, I think. Yeah, it's also reading short. So guys, I think the answer to that question is, can we replace a BGA with this sort of equipment? And the answer is no. Unless maybe you've got extremely lucky, or maybe you're just better at doing the job than I am. But I have to say no. I think it may be possible with an alteration to the equipment, and I'll just show you what I think might possibly do the job with this cheap hot air station. So basically the trick to this is getting enough heat evenly into the job to be able to remove the GPU without effectively causing the GPU to bubble because of excessive heat in one area. And something like this, I'm 170 with the postage to here. I suppose the postage depends on where you are. I am in the Canary Islands. You can buy them for about 160 with postage, I've seen. Or even maybe just like, effectively a hot plate out of a kitchen. Yeah, something like that, a griddle or something, maybe, if you can find a way to support the board. I mean, this is 28 by 27 centimeters, so it's quite big, probably big enough for a motherboard. 1600 watt. Or no, 1500 watts of heating. I think something like this, if you can actually get the temperature up high enough on the board before you start to use the hot air, you may have a chance to do it. I mean, at the end of the day, my BGA station has something like this with hot air above and below. So hot air can do the job. It's just a matter of getting an even distribution of heat into the job. Okay guys, I'm not sure what you expected when we started this experiment. This is pretty much kind of what I did expect, because I have tried to do this before, and this is what happens every time, to be honest. But if you've got any suggestions of something no more expensive than I'm using that might do the job, I have more old graphics cards like this that I'm willing to sacrifice in the pursuit of knowledge. Yeah, so look, I hope you enjoyed this anyway, even though it was a failure. I think sometimes proving something is a failure is an education in itself. But let's see what you think, and if we'd like to carry on down this route, yeah, I'm happy to give it a go. Over to you guys now. Ciao for now, and see you soon.